Okay, in this video, we're going to look at some applications and we're going to look at quadratic equations too. So here we have the quadratic equation is a polynomial equation of the form ax squared plus bx plus c equals 0. And you've seen that format when we've been factoring in order to solve quadratics. So ax is the leading term, bx is the linear term, and c is the constant coefficient or constant term. And we wouldn't have a equals 0 because otherwise then it would just be linear, not quadratic. So here's the square root property that tells us that if we let x is greater than or equal to 0, a is greater than or equal to 0, those things have to be true, then x squared equals a if and only if x equals plus or minus a. So you've probably seen this before, I think, but maybe not in this format. So x squared equals a if and only if x equals square root of a or x equals negative a, negative square root of a. So in the previous video, we were looking at the principal root. Now in this one, we have a different situation because we're not just taking a square root of a number. If you just have a square root of a number, like square root of 4, for example, I wouldn't have a plus or minus situation. I would just say that's 2. I would just do the principal root, right? So if we have a situation where we're starting with something as x squared, though, it's a little bit different because we do have 2 different possibilities. So people get kind of confused with that. Sometimes they want to make this have a plus or minus, but it wouldn't be. It would just be square root of 4 is 2. But here we have a square on a variable, so that's a different situation. So if I were looking at this and I wanted to get x by itself, I have to do the inverse operation, perform that, just like I do with, if I'm adding something and I want to, undo that operation, I would subtract. If I were, had like a 3x, right, and equals 6, I would divide both sides by 3. I would do the inverse operation, right? So similarly with here, the inverse operation to squaring is square rooting, right? So we're going to take the square root of x squared, and it's an equation, so I can do that. I can take the square root of both sides. But when I do that, I have to write plus or minus because we know that x could be a negative there and give us the same result. So once I do this, I get x by itself. And then if I take the square root of 64, that would be 8. So I have plus or minus 8 for an answer. Now if I do a check on that, let's see if it works. 8 squared equals 64. Yes. 8's kind of funky looking. Negative 8 squared. Remember to use parentheses when you're plugging in. The negative is inclusive in the base. Does that equal 64? Yes. 64 equals 64. Okay, so that's the idea with this. Again, we're not going to worry too much about simplifying and things like that, but so we're going to skip these. But if we have a situation like B, again, we could take the square root of both sides, but we have to do plus or minus. Then we would have x by itself, and we would have a plus or minus square root of 75. You could figure that out on a calculator. If it were a word problem, we would round. But if it weren't, we would want to simplify that. So I'll show you both ways. So we have plus or minus, and then square root of 75 can be broken down to 3 times 25. And then square root of 25 would be 5. Now make sure that 5 goes right next to the radical. Square root 3 would be left. And if I wanted to approximate, I would get plus or minus 5 times square root of 3 would come out to be, if you hit usually the second key on your calculator and then the square root and then hit the 3. Make sure you arrow over if you're on that multi-view to get out from under the radical, then hit enter and you'll still see radical 3. So then hit those double arrows right above the enter button. It's a toggle switch. And you would get 1.732 ... times your 5, and this entire answer would equal approximately, that's what that symbol means, 8.66025. So I'm just going to round off to 8.66. I'll write out what I'm doing here though. Generally, we go 2 places. So this, again, x equals plus or minus 5 square root 3, or sometimes we just say radical 3. That's an exact answer. And this is an approximated answer. Kind of the same deal when you have something in as a pi, you know, like 2 pi is an exact answer, where if you calculated out pi on a calculator, you would have it be approximated. Okay, so having that background information of how to take square root of both sides and such, if we have equations with an application, we're going to look at the Pythagorean Theorem. A long time ago, a Greek mathematician named Pythagoras discovered an interesting property about right triangles. The sum of squares of the lengths of each of the triangle's legs is the same as the square root length of the triangle's hypotenuse. This property, which has many applications in science, engineering, and architecture, is now called the Pythagorean Theorem. And I can put up a little video clip of how that's proved out. I usually do that in Math 99, but you might be interested in that now. So I can pop something up there of how that works with a grid and stuff. If A and B are the lengths of the legs of a right triangle and C is the hypotenuse, then the sum of the squares of the lengths is equal to the square of the length of the hypotenuse. So we have A squared plus B squared equals C squared. And you may or may not have seen this somewhere along your math career, but if you have, you probably have, but it might have been a while and you may have forgotten it. So we're going to look at how to solve some of these things out. Example 11.11. And like I said, we do it again in Math 99, but in a more complicated way. Find the length of the missing leg given the hypotenuse is 9 centimeters. Now I'm going to say, I know this is a typo because it tells me the other leg is 15 centimeters. And I know that my hypotenuse C, this is my hypotenuse, is always my longest side. So there's no way that could be 9 and a leg is 15. So we're going to say the hypotenuse is 25 centimeters, okay? So make sure you rewrite that, get rid of that 9 and make it be 25. And then the other leg is, there's one that's 15 centimeters. So we'll call that one. Usually we say B. It doesn't really matter, but. And then A is the unknown. So we can just leave it as A. So we're this is a standard formula, so we're just labeling right onto our diagram. Here is fine. Okay, so then I'm going to write down, I have the formula. If it wasn't there already, for sure you'd want to write it, but A squared plus B squared equals C squared. So now I'm just going to fill in A, I don't know, so I'm leaving it just as A, okay. B is 15, put parentheses and then squared, although I wouldn't have any lengths that are negative, so don't need to worry too much. And then 25 squared is my C on the right hand side. So I have to calculate these out. I can actually just rewrite this. First, I can write it as a squared equals 25 squared minus 15 squared. Now, don't be tempted to just, add those together or subtract those and square it. You have to be a little more careful than that. But what we're going to do is calculate out. So we have a squared equals 25 squared. So 25 squared is going to be 625. And then 15 squared is going to be 225. So now we will get 625 minus 225 is 400. Now I want to take the square root of both sides. And again, it's plus or minus technically on that side. So then we get a equals square root of 400 plus or minus. But in this case, because it's a length, we always would want the positive. Now, square root of 400, I would want to simplify that. So I could write that as square root of 100 times 4. If I didn't know right away, what it would be, I could break it down. And I know square root of 100 is 10. And square root of 4 is 2. And so I would get 20. But you might be able to just pick up right off the bat that that's going to be 20. So that is going to equal 20 centimeters. And then you can check to make sure. So you would do a check and you would do 20 squared plus 15 squared. Does that equal 25 squared? So just double check. 20 squared does in fact equal 400. 15 squared was the 225, so that's 625, and that is the same as what we got for our c squared. So that's basically all it is to that. When we have a missing leg, it's a little trickier than when we have just a straight out one. This one, example 11.12, is pretty straightforward. I'll just draw a quick sketch on this one. These always have to be right triangles, so that info would be given to you. Obviously my triangle up there is not quite to scale, but if I had my lengths of the legs are 16 inches and 12 inches, find the hypotenuse. Okay, so always make sure you remember to take this square root when you're doing these two. So I would have a squared plus b squared equals c squared. A squared is 16 squared plus b squared is 12 squared equals c squared. Now remember, you can't just add these together. You could clearly see that wouldn't work from the problem above. You wouldn't get the same answer if you did that. So 16 squared, and you can use a calculator for this. So of course it's a little trickier. So 256 plus 12 squared, that one we should know off the top, is 144. Equals c squared. Add those together and we get 400. Same answer. Is c squared. So then we already figured that out before, that's 20. Kind of a fluke because I changed the value because we had a typo. So 20 inches is side C. So you would write in a sentence, the hypotenuse is 20 inches. And that's really it for our purposes here, just to get you familiar again with reviewing the Pythagorean Theorem, and then Math 99, you'll be working with it in more detail. Have a great day.